To help us keep track of information as we work through a puzzle, we're going to introduce two pieces of notation. The first is called a center marking. This is a collection of numbers written in a small font in the middle of a cell. This notation is a list of the values that are still logically possible for the cell. Initially, a blank cell could theoretically be any of the 9 digits, but as we examine the row, column, and box, we can eliminate some of those possibilities. In this example, we can eliminate the numbers 1 through 7 by looking at the row, column, and box. This means that the cell must either be an 8 or a 9, but we don't know which one, so we can put an 8-9 center marking to help us remember this. While it's technically possible to go through every cell and fill them in with center markings, this makes a very cluttered grid that makes it hard to see the important information, so you typically only do this when there are 2 or 3 possibilities. The second notation is a corner marking. We use this to indicate the only places in a box where a particular digit can go. It will make more sense after looking at an example. Let's think about the digit 2 in box 7. If we eliminate the rows from the other 2's, we can see that the 2 in this box must be in one of 2 places, so we put a corner mark in those 2 cells. We have not restricted the values of these 2 cells with this notation. All it says is that one of them must be a 2. The value of these markings is that it reminds you of information that you've already deduced, so you don't have to remember it later. As you complete more of the puzzle, you can look back at these markings and potentially continue making progress. With center markings, you can always recheck to see if any of the values have been eliminated as you've continued solving. And it's much easier to just check a couple digits instead of having to work your way through all of them over and over again. Here's an example of how this may play out. Suppose we've got a grid like this, with a center mark of 3, 7 in row 2, column 3. And let's suppose that we are able to deduce that row 6, column 3 is a 7. We can then immediately deduce that row 2, column 3 cannot be a 7, because that would lead to 2 7s in the same column. That means that this cell must be a 3. For corner markings, the logic is a little different, but the core idea is the same. Here's an example. Suppose that we are able to deduce the value of row 5, column 4, and that this is something other than a 2. This would leave exactly one corner marked 2 in the box, which means that there is a 2 in row 6, column 4, because there's nowhere else in the box that the 2 can be. These 2 examples show how this notation can help us solve puzzles. In the next video, we'll see some of the logic that can be applied to the markings.